Everyone got it? You able to graph those 3 points and they showed up? So control 2 is for an individual point. Okay, next thing. So when I just made that appear, what did I make appear? What does that curve consist of? What's that? That curve consists of the 3 points. Is that true? What does that curve consist of? More than 3? Yeah, a lot more than 3, right? So that the whole curve is like a zillion points. And so what about the points that we plotted, right? So those points are basically highlighting the points that were already there on the curve, okay? So your second goal here is to make, in one command line, you're going to make your graph look like mine. So you're going to, in one command line, write the math behind that set of points, right? You're going to put the math into GC that represents that set of points, and then GC will graph that set of points. You don't have to whisper. You don't have to whisper. No. What's that? No. You just forget about that. That's just my file has that to show you the different aspects. 10. Where's y negative? So whenever you use lowercase n, that's one of the things that's reserved in GC. As soon as you type a lowercase n, this will pop up, and this is what's called a slider. Okay, so it's a way. Have we seen that before? Have we done this before? So it's a way of having a variable, right? So either you can push play and let the variable vary, or you can grab onto the button and manually change the value of the n. So what I'm showing here is a point that has varying values, but still maintains that relationship. So it's kind of, as n varies, it highlights every point on the curve. So you get one command line to do that. So, and as you notice, what values is n taking on here? You notice what values n is taking on there? According to what's the point that's displayed? What's the x value? Is that right? Is n taking on the x value of the point?
Yes, but like as a restricted domain.
I'm just asking about what value is n taking on. That's all I'm asking. He suggests x. Is it taking on the x value?
Yes.
Agree with that? So the points at x equals 1, the points at x equals 2, the points at x equals 3, the points at x equals 4. So, okay, so that's your hint to get started. So you're going to do one command line to recreate this. One command line so that it graphs this varying point, right? This varying point. Yes. I like varying better than movable, right? No. First of all, there's no function f, and a point has 2 coordinates. A point has 2 coordinates. What point is it plotting when n is 5.68? No, a point has 2 coordinates. A point has 2 coordinates. What point is it plotting when n is 5.68? 5.68 square root of 5.68. That's the point it's plotting. All right. What about when n is 8.64? What point does it plot? But what point does it plot?
8.64.
Right. It plots the point 8.64, square root of 8.64. When n equals 2.04, what point does it plot? Right. So now let it go. Here we go. Anyone get it yet?
Yes.
Very good. Okay. But why does 0 less than equal to n less than equal to 10? Oh, so that it stops. Okay.
Yeah.
So to change the slider range, you're going to click on the n. If you want to change the range of n, click on the n and then you do it here. Okay. So we only restrict x and y because that's x and GC means spray all the x values at once. But since we're taking n values one at a time, we don't do that in the math line. You just click on the n, and then you can decide what your lowest value, highest value, and number of steps is. So, did you get it? So go back to. But so n is a value, so n doesn't equal a whole point, right? A point is two values. So like when I graph this one right here, here's n is 2.04. What point is it graphing? Right, it's graphing 2.04, square root of 2.04. So what will the general structure of this look like? Right, and now when n is 7.92, what is it graphing? So what should we put in here? Is that right? So right now when n is 7.92, will it graph the right point? If you did that? If you did n square root of n? Well, no, not I hope so. If you were to put this right now, what point would it plot? Yeah, right now, what point would it plot?
7.92 square root
Yeah, there you go. See it? So that's, yeah. Did you guys get it over there? Okay, so now, if I remove my, a little more challenging one here, but you can do it. Just use, yes, no, you can, not probably. Where is it? I gotta look up there. If I go to graph, if I take off my axes, you'll see there's something else that I'm graphing there. But you haven't written the math for this yet. So what? First of all, what am I showing here? Can you describe a conceptual? Give a conceptual explanation of what I'm showing now on the axis.
The rate at which the dot is moving?
Am I showing you the rate?
No. Well, yeah, no, you're not.
Okay. Veronica. How x and y are increasing? What do you guys think about that? Or just a different representation of x and y, right? All right, just representing the x coordinate of this point. How am I representing the x coordinate of that point? Rather than just as a place on the graph, I'm representing the x coordinate as so this point showed a particular x coordinate, right? Or for any given value, and it shows an x coordinate. But then how is this blue bar showing the x coordinate in a different way? Okay. Right. So the length of the bar isn't that the x coordinate, right? And that's how we define the x-coordinate, right? It's like how far to the right you are. So this is actually showing it as a length, right? It's actually showing the x-coordinate as a length, and then the corresponding y-coordinate as a length. Now, for you to create that, we need to think about those bars as what? So how are you going to think about those bars to create the animation?
So wouldn't y always be 0 if we're going to start moving?
Okay, so you're kind of past my question. So that's good. But my question is, how do I conceive of that blue bar when I'm typing something in? What am I conceiving it as? What am I thinking of it as? X values? What's that? Points, right? Points. Everything that you want GC to display is either a point or a set of points. So now you got to take that blue segment and imagine that as a set of points. What's the mathematics behind that blue set of points? What's the mathematics behind this red set of points? So, what is it most similar to what we've done previously in this exercise? But of all the things that you've created so far, which of the things is this blue bar and this red bar most similar to in everything you've created so far? He wants the curve. Right. Essentially, it was a relationship, not a function, right? We never defined a function per se. We could have, but to do it in one line, we just did y equals square root of x. So yeah, so we're graphing a string of points, right? Like either the curve. So now this line segment is really no different than graphing that string of points, but it's dependent on what? N, right? So we know we're going to be graphing a string of points, just like we graphed the square root curve, but now somehow it's going to depend on N. Okay, so I'll let you go now. What's the x-coordinate of that point now? 2.12. What's the x-coordinate now? 8.08. What's the x-coordinate now? 5.6. So how that bar goes from 0 to... Everyone good here now? We got it? Okay, so for Thursday, there's like a 4-page there's a 4-page activity that is a great activity that's working with function notation, sliders, the n slider, and points, and functions, graphing functions. Puts it all together. So it puts together most of the stuff that we've learned about graphing so far. And that will be due on Thursday. Let me show you what it will look like in the end. By defining this function as a function for, I'm going to post it on as an assignment. Like I said, 4-page activity, and it'll take you through, and as you're working through the activity, you'll be building this file, okay? You'll be building this GC file. It starts with this function of expected attendance at a football game given the temperature, right? So given the temperature outside in degrees Fahrenheit, what's the expected attendance in thousands at a football game? And so by the time you're done, this is what your file, this is what the activity will take you through, and you'll be building this file. And so most of what we just did in this activity in class is going to apply to this, but the 4-page handout is going to be walking you through it. Okay? And that'll be due. The GC file will be due at the beginning of class on Thursday. So you can email me for help. Don't hesitate to do that. But this is what you're going to come up with, okay?